Maths, chapter Triangles, new session, and it is the 16th one. Alright. In the previous session, we completed solving the exercise 6.4. Now we proceed further with few important theorems. Alright. The first one, theorem 6.7. Well, it is already proved by me. And I told you, if you remember, we will use this theorem when we prove Pythagoras principle. Okay? So let's revise it. If a perpendicular is drawn from the vertex of right angled triangle to the hypotenuse, then the triangles on both the sides of perpendicular are similar to whole triangle and to each other. Alright, very quickly I draw a right triangle. Okay. This is right triangle ABC. Fine. Now, if a perpendicular is drawn from the vertex of right angle, which is right angle B. So, vertex is B. If you draw perpendicular to the hypotenuse, so hypotenuse is AC. So, if I draw perpendicular from B to AC, suppose this foot of perpendicular is D, then you have two triangles on the two sides of perpendicular. Red line segment is perpendicular. We have triangle ABD and triangle BDC. Alright? So what the statement says? Then triangles on both the sides of perpendicular. Both the sides of perpendicular, that is the side BD, two triangles, are similar to the whole triangle. So green triangle is similar to black, and blue triangle is similar to black, and green triangle is similar to blue. Are similar to whole triangle and to each other. I'll show you the proof once again. It's very easy. Alright. I'm talking about green triangle and black triangle. In green triangle, this angle is congruent to this angle of black triangle. So black triangle angle ABC, which is right angle, is equal to angle ADC, the green angle. And one angle is common, which is common angle. You can see green A and black A. So angle BAC of black is equal to angle BAD of green. So by AA criterion, ABC, I am writing directly, ABC corresponds to dash 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 is similarity by AA criterion. Now, follow the correspondence. B corresponds to D. B is in the center, D in the center. A corresponds to A. A is first A. The left out is A, D and B. This correspondence is similarity. So you got then the triangles on both sides. Triangles on both sides. First we got green triangle is similar to whole triangle. Where is whole? Yeah, whole triangle. That means the black triangle. A black triangle is similar to green triangle. That we got. Now we have to prove blue triangle is similar to black triangle. Again, you see, what is that? Right angle B, angle ABC is equal to right angle blue, that is angle BDC, angle BDC. Okay? And the common angle, very clear, angle C, blue C and black C. So angle ACB, black angle ACB is equal to blue angle DCB, angle DCB. Therefore, ABC corresponds to dash 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 is similarity. Once again by AA criterion. Let's see what B corresponds to. D. B in the middle, D in the middle. C corresponds to C. C is last, so C is last. And what is left out? C and D is obtained, B is left out. So fill in the blank with B. So ABC corresponds to BDC is similarity. This is result 1. This is result 2. Alright. Now you see ABC corresponds to ADB. Same ABC corresponds to BDC. So by 1 and 2 you can say green one. That is same order. ADB corresponds to BDC. BDC is a similarity. Alright. So this is the third result. So you can say green is similar to black, blue is similar to black, and green is similar to blue. So triangles on both sides of perpendicular are similar to whole triangle and to each other. Got it, children? Sure? Understood? Okay. Proof is not given in the textbook, but I have explained and I have done it before. Okay? I think in the first or second session. Okay? Fine. Now, from this I get one more result, children. Okay. Here, okay, which points are common? A is there in both and B is there in both. So if I pick up AB from here, I'll get upon AD. And if I pick up AB from this, here I'll get AC. So that is equal to AC upon AB. If you cross multiply, you get AB square is equal to AD into AC. Very important result. If you remember, I called it geometric mean. Geometric mean. AB is called geometric mean of AD and AC. That means AB square is equal to AD into AC. From here, what is common? B is common here. What else? Yeah, C is common. So if I pick up BC from here, I'll get corresponding side CD is equal to. And if I pick up BC from here, the corresponding side is AC. So AC upon BC. AC upon BC. Cross multiply. So BC square, BC into BC is equal to CD into AC. This is the second result of geometric mean. And the third result, yes, what's common in this correspondence? D and B. Alright, if I pick up BD from here, the corresponding side is CD is equal to. If I pick up BD from here, the corresponding side is AD. So you get AD upon BD. Cross multiplication. BD square is equal to AD into CD. So this is the third result of geometric mean. Please look at the first result. AB. Children, where is AB? Here. This AB is one of the side forming right angle. Is equal to AD, the segment adjacent to it. AB के साथ जुड़ा हुआ part into hypotenuse AC. So AB is geometric mean of AD and AC. So we can say AB square is equal to AD into AC. Now second, this one, BC. BC is the other side forming right angle. Right angle form करने वाला दूसरा side is equal to CD. That is this part, CD. The segment connected to BC into hypotenuse. CD into AC. So BC is geometric mean of CD and AC. So you can say BC square is equal to CD into AC. And the third one, this one, the perpendicular, or it is called altitude. Either you call altitude or you can say perpendicular from B to hypotenuse. So what that result gives us? There it is, BD square is equal to AD into CD. Can you see that? AD into CD. So BD square is equal to AD into CD. So we have, okay, I'll erase this and draw a new figure giving different name to it and we'll see the result. दो रिजल्ट, बहुत ही इंपॉर्टेंट रिजल्ट है चिल्ड्रन. Theorem 6.7 talks about similarity, and from the same theorem you get result about geometric mean. Okay, let's see. Here is one triangle A B C. See, कुछ और I'll give different name. M P A. चलो, which is the right angle M. So from M I draw altitude या perpendicular to the hypotenuse. Let the foot of perpendicular be X. Now you know this triangle is similar to red triangle. Red triangle में बोल दूं AMP corresponds to, अभी आपको डायरेक्ट लिखना है. Okay, which is right angle in the red triangle? M. So that M. And which is the right angle in black triangle? X. So M corresponds to X. Which are the common angle? P. So P corresponds to P. And which is left out? X M P. X और P आ गया, बच गया M. Is similarity by theorem 6.7. आपने डायरेक्ट लिखा by theorem 6.7. Now let's see this green part. All right, उसका नाम बोल दूं AMX. All right, I'll take this. Okay, AMX corresponds to, बोलो, dash 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 is similarity by theorem 6.7. बोलो, which is common angle A? Red angle, green angle A. So A corresponds to A. What is right angle here? X. And what is right angle in the black? M. M is right angle and here X is right angle. So M corresponds to X. A और X आ गया, बच गया M. So this correspondence is similarity by theorem 6.7. अभी देखो चिल्ड्रन, if I write AMP corresponds to dash 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 is similarity. Now what does A corresponds to? Oh, I made mistake here. Correct. Green and black. A corresponds to A. So you should have red A. Chalo. Right angle green is X. X last. And right angle red is M. So last. So what is left out? P is left out in this. So APM आएगा. क्या आएगा? APM. If I change the order, इसका ऑर्डर सेम करने के लिए मैं लिखूं यहां M और यहां P, तो यहां चेंज करना पड़ेगा आपको, ताकि हम लोग डायरेक्ट कंपेयर कर सकते हैं. AMP तो ये डायरेक्ट कंपेयर कर सकते हैं, राइट? ओके, लेट्स सी. रेड M is right angle और green X is right angle. So बीच में X, green A और red A, so A corresponds to X and the left out is M. So now you can say AXM corresponds to AMP is a similarity. ये दोनों सेम है, देखो, तो डायरेक्टली यू कैन राइट AXM corresponds to MXP is similarity. वो दोनों correspondence पाने के लिए. Alright, so these are the results. Yes, geometric mean result, which is the side forming right angle PM. PM is one side forming right angle. So PM square is equal to PX into PA. PX into PA. Next side forming right angle is AM. So AM square is equal to the segment adjacent to that AX into the whole side AP. Yeah, PA. And then the third result, MX square is equal to PX into AX. PX into AX. Children, ये right side पे जो भी है वो the two parts of hypotenuse and the hypotenuse are involved. Okay, fine. All right, now we are moving to very important theorem, quite often asked in the board examination. Children, theorem 6.8, it is also called Pythagoras theorem. Pythagoras theorem, उसे Pythagoras theorem भी कहते हैं. And what is the statement? In a right triangle, so you have a right triangle. In a right triangle, let's say ABC, in a right triangle, the square of hypotenuse, this is hypotenuse, the square of hypotenuse is equal to the sum, means the sum of squares, so squares of the other two sides. If AC is hypotenuse, then which are the other two sides? AB and BC. I'll read the statement again. This is called Pythagoras theorem. This is the statement of Pythagoras theorem. Okay. In a right angle triangle, so here is right angle triangle. The square of hypotenuse, so here it is square of hypotenuse, is equal to, here it is sum, here it is the sum of squares of other two sides. Squares of other two sides. Okay, children, this theorem is very easy. For that we will be using theorem 6.7, which we saw earlier. Okay, but let me tell you, I have written or. In triangle MNO, angle O is right angle. Then prove that MN square is equal to NO plus NO square plus MO square. Children, this was the statement asked in the board examination March 2020, and most of the students did not understand. I don't know why. Because only this, instead of ABC, the triangle given is MNO, and instead of B is right angle, angle is 90. क्योंकि सब स्टूडेंट्स ये स्टेटमेंट को ही याद रखते हैं और स्टेटमेंट में कुछ भी ट्राइंगल का नाम नहीं दिया, so everyone mostly writes triangle ABC. In the textbook also it is given triangle ABC. Are you getting me? और बोर्ड एग्जाम में क्वेश्चन थोड़ा ट्विस्ट कर दिया, and most of the children were not able to write. Very sad. Okay, so what I am going to do, I am going to use this only and see how you can prove it. Okay, I am drawing the figure first. It's a right angle triangle. Angle O is right angle. Let's say this is M and this is N. Data. Angle O is a right angle in triangle MNO. To prove, so easy, data into prove. MN square is equal to NO square plus MO square. Proof. बोलिए चिल्ड्रन, ये हमने देख लिया है एक रिजल्ट which we get from theorem 6.7. theorem 6.7 से हमें एक रिजल्ट मिला था, geometric mean, जिसमें squares आते हैं. Now this is one of the side forming right angle, so you can say MO square is part upon whole, NO square is part adjacent to this side, this into whole. But where are those parts? And those parts we get after dropping perpendicular from vertex O to hypotenuse. MN is hypotenuse. So first thing I'll have to do is drop perpendicular. O A. Let me say O A. Alright. So let OA be perpendicular to MN such that M dash A dash N, M dash A dash N, call it result 1. हमने पहले perpendicular draw किया, altitude draw किया on the hypotenuse, right angle triangle के hypotenuse के ऊपर perpendicular draw किया. Okay, check. Now, therefore, bolo, which triangle? I'm going to talk about this triangle and the original triangle. Therefore, a correspondence, MNO corresponds to dash 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 is a similarity by theorem 6.7. Chaliye, which is right angle in MNO? O is right angle, and here in this triangle A, so O corresponds to A. Now, which is the common angle? M, ये corner वाला, OMN and OMA. So M is equal, so M corresponds to M. Now, what is left out? O, so that you can fill in the blank. All right. Therefore, which are common here, children? दोनों में M है और O है. So I pick up MO from here, MO upon. From here I get MA is equal to. Yes, if you pick up MO from here, here you will get MN. So MN upon MO. So cross multiplication. Therefore, MO square is equal to MA into MN. Result 2. Correct? Also, now you take this triangle. Alright? Also, a correspondence. Which one? MNO. वो तो लिख ही देता हूं. MNO corresponds to. चलो, right angle in this O. ये. Right angle is O. And right angle here A. So O corresponds to A. The common angle N. So N corresponds to N. N और A आ गया, बच गया O. Is a similarity by theorem 6.7. Got it? अब common points कौन से है यहाँ? एक तो N है और O है. यहाँ से NO. If I take तो upon I'll get Na. Correct? और यहां से NO लूं तो यहां से Mn आएगा. So Mn upon NO. Therefore, cross multiplication. NO square is equal to Na into Mn. This is result number 3. Got it, children? Result number 3. Fine. I'll erase this part. We are done now, children. What we have to prove? Mn square is equal to No square plus Mo square. Now look here. No square, it's here. Mo square, it's here. And we have to add them. So by 2 and 3, sum of left hand side is equal to sum of right hand side using Euclid's property. So I'll write here by 2 and 3. It follows that. What? Mo square plus No square is equal to, right side now, Ma into Mn plus Na into Mn. Children, what is common here? Mn. So factorize it. Mn is common. In the bracket, Ma plus Na. Now look in the figure. Ma is this part. Ma plus Na is this part. So Ma plus Na will be Mn. So that is equal to Mn into Mn by 1. क्योंकि वहां 1 में क्या है? M dash A dash N. So Ma plus Na is equal to Mn. Or you may write, because M dash A dash N in the data. Correct? Okay? Fine. So what is Mn into Mn? Mn square. Therefore, Mo square plus No square. What you got? Mn into Mn. Mn square. i.e. you can say mn square is equal to, yes, no square plus mo square, or you may write mo square plus no square. No square पहले लिख देता हूं plus mo square. Proved. So simple. That's it. This is Pythagoras. But when you want to prove Pythagoras theorem, you have to start by dropping perpendicular to the hypotenuse. Alright? Understood? This theorem is important. Yes, it was asked in 2020. So the chances of being asked again in March 2021 is less. But still, it's very important. Yeah. Next, we move on to theorem 6.9, which is converse of Pythagoras. That is also very important, and it has the chance of being asked in the next board examination. I hope you understood this. Let's move on to the next theorem, theorem 6.9, and it is exactly the converse of Pythagoras. Alright? In a triangle, it's not right triangle, in a triangle. It is right triangle, but we have to prove. So here, in a triangle, if square of one side, any one side, the longer side, square of one side is equal to the sum of squares of the other two sides, then the angle opposite to first side is a right angle. Alright, let's see it. Okay. Children, take care. See what I have done. What type of triangle is this? You might say right triangle. Yeah, it looks like right triangle. But unless and until I don't make right angle sign here, don't say it's right angle triangle. It may be 89 degree or it may be 91 degree. Yes, if I make this sign, then it is confirmed that is right angle. So now the sign is not made. And we have to prove that. That is right angle. Prove that. That is right angle. Okay. Now this is triangle ABC. Data. Okay. First we'll discuss data. AC square is equal to AB square plus BC square. Okay. Let me write. Data. In triangle ABC. Any one side. Yeah, I have to prove B right angle, so उसके सामने वाला AC square is equal to AB square plus BC square. That first side should be opposite to that right angle. To prove, चलो कौन सी है first side? ये. Please, square of one side, that is square of AC, is equal to the sum of squares of other two sides. Sum of squares of AB and BC, which are other two sides. Then prove that the angle opposite to first side, the first side is AC, and angle opposite to that, angle B is equal to 90 degree. Angle B is a right angle. If you want to write like this, you can write. Angle B is a right angle. Children, you have got this. You have got this. Alright? I'll write all this again. I'll erase this statement also because we'll need little extra space for the proof. Okay? So I'm just discussing now. How to get this? ये है, हमें ये right angle कैसे बताना होगा? How can we show this right angle? Children, I'm going to construct another triangle, which is right angle triangle. And that triangle, I'm going to produce black triangle here. Okay? Which is right angle triangle, and that black triangle is congruent, not similar. That black triangle is congruent to this red triangle. चलिए मैं construct करता हूँ. I've drawn one ray, another ray which are perpendicular to it. This is the ray QX. This is the ray QY. So ray QX is perpendicular to ray QY. If I join X and Y, you get triangle YXQ. But it won't be congruent to red triangle. To make congruent, on this ray QY, I plot point P such that PQ is equal to AB. This is point plotting theorem. ये एक ray है QY, उसके ऊपर एक पॉइंट P ऐसा प्लॉट करूं कि इट्स डिस्टेंस फ्रॉम Q is equal to AB. So I put that. Same way, on ray QX, I plot point R such that BC equal to QR. And now I draw line segment PR. Children, I got black triangle PQR, which is right angle. Now dekh lo, these two are equal, correct? These two are equal. AB is equal to PQ. BC is equal to QR. है कि नहीं? चलो. But this angle is equal to this angle अभी नहीं. So how will you prove these two triangles are equal? अभी साइड साइड है, बीच वाला एंगल लेके तो ऐसे कंडीशन होगा, लेकिन तो ये तो प्रूव ही करना है कि दिस टू एंगल्स आर इक्वल. सो यू कैन थिंक ऑफ एस एस एस. क्या AC इक्वल टू PR है? देखते हैं. नाउ दिस इज राइट एंगल ट्राइंगल, करेक्ट? This is right angle triangle. So the Pythagoras can be used, which is hypotenuse PR. So PR square is equal to PQ square plus QR square. है कि नहीं? करेक्ट? अब क्या करें? देख लो. PQ cross mark, AB cross mark. So PQ is equal to AB. So PQ square is equal to AB square. देख लो QR, ये S side, यहाँ S side. अरे QR equal to BC. So QR की जगह पे BC स्क्वायर. अब क्या करें? What shall we do? अरे बाबा AB स्क्वायर प्लस BC स्क्वायर, डेटा में देखो, AB स्क्वायर प्लस BC स्क्वायर इज इक्वल टू AC स्क्वायर. सो दैट इज AC स्क्वायर बाय डेटा, करेक्ट? Therefore PR square is equal to AC square, taking square root on both sides. So PR is equal to AC. अरे PR equal to AC. This is AC, this is PR. So S by SSS, correspondence is congruence. Here sides are not in proportion, sides are equal. AB is equal to PQ, BC is equal to QR, and now we proved AC is equal to PR. So by SSS, correspondence between red and black triangle is congruence. Therefore आपको correspondence से मिलेगा angle Q is equal to angle B. But Q is right angle, so B is also right angle. Proof. Did you understand, children? I will erase whole thing and write proof nicely. All right. Children, it's very easy and most likely to ask in the next board examination. Very important. Theorem 6.1, Theorem 6.6, and now it is Theorem 6.9. 6.1, 6.6 and 6.9. These three theorems, if you have prepared well, fine. You are going to score 4 marks in this theorem. Okay? Chaliye. Now I will draw that figure. Children, this is triangle ABC. I have not put sign of right angle here. Alright? And then I construct another triangle. You draw rays like this. Okay? बीच में Q. Here R. QR equal to BC. Here P. PQ is equal to AB. This is the ray QX and ray QY, and if you join PR, you get right triangle PQR, and they are going to be congruent. So ये size और ये size same होनी चाहिए, जरा draw करते समय ध्यान रखना. All right? Now I'm writing the data. What is data in green triangle ABC? बोलिए. AC square, square of length of one side is equal to sum of squares of lengths of the other two sides. The other two sides are AB and BC. So AB square plus BC square. To prove, आपको क्या प्रूव करना है? That one side, ये one side, उसके सामने वाला एंगल, एंगल B. Angle B is a right angle. Proof. How do we start the proof? By constructing triangle PQR, which is right-angled triangle. And then we will prove red triangle is congruent to green triangle. Okay? So for that, let ray QX be perpendicular to ray QY. है ना? I'm taking ray QX perpendicular to ray QY. Perpendicular means this is right angle. Therefore, angle Q is a right angle. Okay? Now, very important. Plot point P on which ray? QY such that PQ is equal to AB. Such that PQ is equal to AB. Alright? And plot point P and दोनों अलग अलग लिखने की जगह पे साथ में लिखते हैं. प्लॉट पॉइंट P and R on ray QY and ray QX such that PQ is equal to AB and QR is equal to BC. Call this result 1. Alright? चलिए, draw PR. Therefore, triangle PQR, आपने ये ड्रॉ कर दिया उसके बाद. Therefore, triangle PQR is a right triangle. Therefore, Pythagoras use karo. Hypotenuse is this. You can say this is hypotenuse because side opposite to right angle. PR square is equal to PQ square plus QR square. PQ square plus QR square. By Pythagoras. By Pythagoras theorem. Or you can say by theorem 6.7. Or simply by theorem. Okay? Now, what is PQ? AB. What is QR? BC. So that is equal to PQ AB square plus QR BC. So BC square by 1. Now, what is AB square plus BC square? That is AC square. So AC square by data. Therefore, PR square is equal to AC square. Therefore, PR is equal to AC. Result number 2. I'll put the sign also. Yeah, PR is equal to AC. AC is PR. So, side. ये दो result 1 में है और ये result 2 में है. So, by 1 and 2, it follows that a correspondence dash corresponds to dash is a congruence by SSS theorem of standard 9. चलिए, ये ट्राइंगल का नाम लिख देते हैं ABC और पाथ्स आपको चाहिए. पाथ्स चिल्ड्रन, या ये दो पार्ट में कॉमन क्या है? Q और ये बाजू कॉमन क्या है? B. That's how you can get. ये दो में Q है और ये दो में B है. So Q corresponds to B या B corresponds to Q. B बीच में, so Q बीच में. Now you know Q corresponds to Q. So you can say, Q corresponds to B. So you can say P corresponds to A. Yeah, A corresponds to P. A first, so P first, and left out is R. Therefore, angle B equal to angle Q. जो B हमें चाहिए वो B equal to Q. देख लो, angle B equal to angle Q. But I'm writing here. But angle Q is a right angle. Therefore, angle B is a right angle. Proved. Did you all understand, children? It's quite easy. But don't forget construction of right triangle. How? By drawing two perpendicular rays and then plotting 2 points on it such that PQ equal to AB and QR equal to BC. And then you get AC equal to PR. First you use Pythagoras here and then data name. Okay? And you get it by SSS. I hope you understood. Fine. So let us move on to the next illustration, that is illustration 10. Let's see the statement. In figure below, here is the figure. Angle ACB is 90. Where is ACB? ACB. So it's a right triangle ABC where angle C is the right angle and CD is perpendicular to AB. Array, C is that vertex where right angle is formed. So AB is hypotenuse. So this is perpendicular drawn to hypotenuse. So it is altitude to hypotenuse. So geometric mean के results है. This triangle is similar to original. This is similar to original, and they are similar to each other. And from there you get geometric mean results, mean squares. You got AB square is equal to BC square plus AC square. Pythagoras bhi hai. So plenty of results you get from this situation. Correct? Okay. What do you have to prove? Yeah, BC square is equal upon AB. BC square upon AC square is equal to BD upon AD. It is very simple if you know the results. Children, देखो BC स्क्वायर, देख लो कहाँ है BC, ये रहा, याद करो ज्योमेट्रिक मीन रिजल्ट. BC is geometric mean of BD and AB. Am I right? BC is geometric mean of BD and AB. बट वो रिजल्ट हमें थ्योरम 6.6 से मिला है. सो हमें तो ये लेना होगा, दिस ट्राइंगल. कौन सा ट्राइंगल? जिसमें AB और BD इन्वॉल्व है. दिस ट्राइंगल इज सिमिलर टू ग्रीन. वो प्रूव करेंगे. सो आई गेट BC स्क्वायर इज इक्वल टू BD इनटू AB. नेक्स्ट AC स्क्वायर है. सो हियर इट इज AC. नाउ यू नो दैट AC स्क्वायर is equal to AD, क्योंकि ये adjacent segment है, into AB. So मतलब AB और AD यहां से मिलेगा, ये ट्राइंगल से मिलेगा. So black triangle is similar to green triangle. वो लेना पड़ेगा. So you will get AC square from there. From here you will get BC square. Then if you use Euclid's property and take the ratio, you will automatically get the result. Let's do it. Data. Angle ACB is equal to 90 degree and CD is perpendicular to AB in triangle ABC. To prove, what do you have to prove? Yes, BC square upon AC square is equal to BD upon AD. First, we will focus on BC square. So you already know BC square is equal to BD into AB. But that is reduced result. Directly नहीं लिख सकते हैं. But you got the idea कि triangle ABC is similar to which triangle? कौन सा triangle लेना है? Red line. Okay. बस ये लिखता हूँ. Angle ACB is equal to 90 and CD is equal to AB. और A dash D dash B. A dash D dash B. This is by data. जब ये situation हो तो ये परपेंडिकुलर की एक साइड का ट्राइंगल होल ट्राइंगल से सिमिलर है बाय थ्योरम 6.6. Therefore, a correspondence dash corresponds to dash 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 is a similarity by theorem 6.6. Children, ये बाजू मैं ओरिजिनल ट्राइंगल ग्रीन जो है उसको ये ऑर्डर में लिखता हूं ABC. ऑलराइट. अब देखते हैं ट्राइंगल ABC में राइट एंगल कौन सा है? C, ये वाला. और ये रेड लाइन रीजन में राइट एंगल कौन सा है? D. सो यस, एंगल C corresponds to एंगल D. D लास्ट, C लास्ट, सो D लास्ट. फिर कॉमन एंगल देखो, B एंगल ग्रीन भी है, B एंगल ये रेड भी बनता है. सो B corresponds to B. B बीच में, B बीच में, B और D आ गया, बच गया C. Therefore, कौन सा? BC और BC, यहां से BC लो तो यहां से मुझे BD मिलेगा. Therefore, BC upon BD इज इक्वल टू, बोलिए यहां से BC लाऊं तो यहां से मुझे BD मिलेगा, BC अपॉन BD इज इक्वल टू क्या मिला मुझे, सॉरी 1 मिनट, बी केयरफुल, यहां से BC तो यहां से मुझे BD मिलेगा, तो BC अपॉन BD इज इक्वल टू, यहां से BC लाऊं यहां से, सो यहां से मुझे AB मिलेगा, सो AB अपॉन BC, therefore BC square is equal to BD into AB, result 1, correct, result 1। इसमें हमें BC स्क्वायर मिल गया और वो देखा ही था हमने, BC स्क्वायर इज इक्वल टू BD into AB है। चलिए सिमिलरली बोलो, डायरेक्ट लिखेंगे, ABC corresponds to dash 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 is a similarity, by what लिखने की जरूरत नहीं, because I use the word similarly। अब ये ट्राइंगल C राइट एंगल, यहां D राइट एंगल, C corresponds to D, और A दोनों ट्राइंगल, ये ब्लैक लाइन ट्राइंगल और ये पूरा ट्राइंगल का A कॉमन है, सो A फर्स्ट, बीच में क्या आएगा, A और D आ गया, बच गया C, राइट। अब क्या चूज करना है, AC, सो यहां से AC लाऊं तो यहां से मुझे AD मिलेगा, इज इक्वल, अब AC यहां है तो यहां AB लेना पड़ेगा, तो AB लेता हूं, ये साइड AB और AC क्रॉस मल्टीप्लाई करिए, therefore AC स्क्वायर इज इक्वल टू AD into AB, रिजल्ट 2, करेक्ट, अंडरस्टूड। बस यू गॉट BC स्क्वायर, ये मिल गया, यू गॉट AC स्क्वायर, ये मिल गया, अब उसका रेशियो लेना है, सो बाय 1 and 2 it follows that ऊपर BC स्क्वायर नीचे AC स्क्वायर इज इक्वल टू, तो राइट साइड क्या आएगा, BC स्क्वायर अपॉन AC स्क्वायर, ये BC स्क्वायर अपॉन AC स्क्वायर इज इक्वल टू दिस अपॉन दिस, सो यहां है BD इंटू AB और यहां नीचे है AD इंटू AB कैंसल, एंड हेंस द रिजल्ट BC स्क्वायर अपॉन AC स्क्वायर इज इक्वल टू BD अपॉन AD, prove, got it, it's very easy children। So children, let's see the last sum in the form of illustration 11 in the 16th session, all right, let's read the statement, a ladder CD, a ladder is placed against a wall, here is a wall and then ladder is placed against a wall, and remember on certain walls there are windows as well, something is mentioned somewhat like that, a ladder is placed against a wall such that its foot, if you say this is the ladder, this is the foot of the ladder and this is the top of the ladder, right, ladder એટલે CD, okay, fine, that its foot is at a distance of 2.5 meter from the wall, this is foot, here is wall, the distance of this foot from the wall, यहां से wall तक का distance, that distance is 2.5 meter, and its top, the top will touch the ladder, sorry, top of the ladder will touch the wall, reaches a window, yes, ladder का top wall को वहां टच होता है जहां window है, reaches a window 6 meter above the ground, floor से 6 meters above there is a window, all right, find the length of the ladder, ये पूरा स्टेटमेंट को एक डायग्राम फॉर्म में डालना पड़ेगा, all right, now see, this is floor, मैंने एक horizontal line draw किया which represents floor, here I represent wall which stands erect, and here ladder, this is ladder, this ladder, all right, is AB, black segment represents ladder, all right, point represents window. A point represents window on the wall, which is 6 meter. Okay, let me say this foot of wall. Wall ka foot. The foot of the wall is C. So how high is window from the base? 6 meter. Alright. This is end of the ladder. The feet of the ladder. The feet of the ladder. Yeah, foot of the ladder. How far it is from the base of the wall? Wall se kitna dur? 2.5 meter. So you have represent this statement in the form of diagram. I'll explain again. The red segment represents wall which stands erect to the floor or ground. Black line segment represents ladder where A, the top, touches the window which is 6 meters above the ground. The foot of the ladder B is how far from the base of the wall? Wall se kitna dur hai? 2.5 meter. You are supposed to find the length of the ladder. What in the figure represents the length of the ladder? AB. Let me call it L. Small letter L. Real number representing the length of the ladder. Now the figure tells you the story. Can you find this L? Yes. You have right angle triangle. So use Pythagoras in right triangle ABC. Angle C is right angle. So hypotenuse is AB. AB square is equal to AC square plus BC square by Pythagoras. Pythagoras, right? Therefore, AB square, AB, we called it L, that length. L square is equal to AC square, 6 square. BC square, 2.5 square. That is equal to 6 square, 36. 2.5 square. 5 square is 25.4, 3 2s are 6. It is 6.25. I'll add 36.00. Point below point. After point is 2, 5. Before point is 6. 5, 2, 2, 4. So that is equal to, therefore, L square is equal to 42.25. Taking square root on both sides. So square root of L square equal to this. Therefore, L is equal to square root got. Square root of 4225 upon 100. I'll remove the decimal. Now this is very popular number. It is perfect square. So नीचे का जवाब आ गया 10. Square root of 100 is 10. But what about square root of 4225? Let's see factorization method. 5 से divisible है, direct 5 से ले लेता हूँ. 5 is 40, 5 4 is 25, 5 is 5 1 is 5, 5 6 is 5 9 is. This is 13 13 is and 13 1 is if you remember. So 13 into 5, 65. ये pair में से 13 और ये pair में से 5. 13 5 is 65. So that is 6.5. Therefore, L is equal to 6.5 meter. You may write the answer. The length of the ladder is 6.5 meter. I hope you have understood. So here we end up the session. Goodbye. Have a good day.